Hello students, today we are going to solve a problem from JEST 2022 and this question basically a part of circularly polarized light as well as laser physics. Okay, so in that question they have given a circularly polarized light CPL having intensity or having power. They have given power P is incident on a particle, and let us assume this particle is capital M. Is incident on a particle, and this particle is basically initially at rest, so V naught will be 0. And this particle completely absorb this power. So the question is, what will be the kinetic energy of this particle as a function of time? And they have given these four options: Pty2 into Pty mc square plus 1. Okay, then second option Pty2 mc square minus 1, and option C that is given p square t square by twice mc square, and option D that is given simply Pty2. Okay. So let us check which option will be correct. Okay. So as we know, we are going to solve this question solution. We know when unpolarized electromagnetic light is incident on a particle. Let us assume this particle is there. Then if this particle completely absorb this power P, okay, then radiation pressure I can write. Radiation pressure P that can be written as I by C, right? Where I is the intensity of incoming beam. And we know pressure is nothing but force per unit area. Also, intensity can be written as power that is given capital P by area into C. So this A will be cancelled with this A, and F is what? F is force. So I'll use Newton's law. So F is nothing but m into dV by dt. Okay, and this m is given. M is the mass of this particle, and that will be how much? That will be P power divided by C. Okay, so from here I'll get dV will be P dt by mc. Okay, now if I integrate both sides, at time t equals to 0, the particle speed was 0. At time t equals to t, let us assume that speed is v. So I'll calculate this speed as a function of time. That will be how much? That will be simply, that will be pt by mc, right? Pt by mc. Okay. Now I can calculate the kinetic energy of the particle as a function of time, and that will be nothing but simply half m v t square, right? So I can write m by 2, and Vt is given, that is E square t square by m square c square. So it will basically give you E square t square by twice m c square. Okay. So this will be the kinetic energy of this particle m, when this beam is unpolarized. But in question they have given the beam is actually circularly polarized light. So as we know, for unpolarized light, you will have one electric component in your wave. But In circularly polarized light, you will have two component of electric field. You will have two component of electric field. Okay. And the light is actually polarized. So for two component of electric field and polarized light, definitely the pressure, the kinetic pressure of field by this particle for two component of electric field and polarized light, pressure feel by this particle will be high. Okay, pressure feel by this particle will be high, and of course, if pressure is high, definitely the speed will be high. The speed of that particle will be high. So if the speed will be high, so definitely the kinetic energy of that particle will be high. So this is the case for unpolarized light. This will be the kinetic energy of unpolarized if the light is unpolarized. But if this light is polarized and it is circularly polarized light, then kinetic energy will be higher than this part. Okay, and that so if you check that option according to given option, so this part also contained in option A. This part is also contained in option A as well as option B. But in option B, there is some subtraction. So this subtraction cannot be possible because that light is circularly polarized light. But option A contains some additional part. So that represent that pressure feel by kinetic energy of that particle will be higher than that. So option A should be correct. So this option, and this is the option C actually. So this option C will be correct when that ray is actually unpolarized. But since this light is polarized and it is circularly polarized light, obviously the kinetic energy will be high. So correct option will be what? According to that given option, kinetic energy of this particle, I can write that will be Pt by 2 into Pt by mc square plus 1. Okay. So this will be the correct. So this plus 1 due to some additional term. This is due to circularly polarized light. Okay. Thank you.